Hi, good to see you again. Welcome to Block 2, Developing Geometric Reasoning, Lesson 10. I'll share my screen. So, in your previous lesson, you learned about parallel lines and transversals of those parallel lines by investigating them, looking at different situations, and you learned how to identify corresponding and alternate angles. In today's lesson, you're going to have in-depth understanding of solving different problems by using those parallel lines angle rules that you learned in your previous lesson. Remember to like the video, share the video with those you think can benefit, subscribe to the channel, and click on the notification bell so that when new videos are released, you'll be notified. Thank you. Before we start, I would like you to pause video and answer these retrieval practice questions in 2 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. So for the first one, you were asked which line segment is a transversal. So by now, we know that the transversal is the line that cuts across the parallel lines. And the lines we see that cut across the parallel lines CD and EF is AB. So line segment AB is the transversal. Next, you were asked to complete these sentences. So this is to help you recall the geometric facts that you have learned so far. So corresponding angles are equal, alternate angles are equal, vertically opposite angles are equal. Let's do some new learning for today's lesson. Angle RWU is marked. So this is our first example. Our angle RWU is marked on the diagram, and you can see it here. So by now, you know how to read angles. You know that the middle letter tells you the location of the angle. So angle RWU. So it's this angle here, RWU. And then if we're required to complete this statement, we can say angle RWU is alternate to angle TVQ, right? You can see by now you know how to identify alternate angles, and you can see that invisible Z shape. Just visualizing it, it's on its side. You can see it right there. So it is alternate to angle TVQ. TVQ. So notice how we read the angles. The middle letter tells us the position of the angle. Angle RWU is corresponding. So RWU. So which corresponding would we find? Of course, you know F shape links corresponding. So it has to be here. It has to be here. And then we can say that angle is corresponding, that position there. And then it is PVU. All right? PVU. Okay. It's time for you to practice what you've learned. Pause the video and answer questions 1 and 2 in 4 minutes. Assuming you've paused the video and you've answered questions 1 and 2, here are the answers. Let's discuss them. So for question 1, you were simply asked, are the pairs of angles alternate, corresponding, or neither? So here we can see that they are corresponding. You can see the invisible F shape that is upside down. You can sort of see it there. And the angle is in the same location in the similar location of the F shape. Here it is neither. We can't really see any link between these angles. Here we can see they're alternate. You can sort of see the weird Z shape that links them. All right. So they're alternate. For question 2, you were asked 4 angles are labeled on the diagram. P and Q are alternate angles. Measure the sizes of each angle and label them on the diagram. What do you notice? And then complete the sentence. Okay, so here you just require to, measure them. And you can see what we notice is alternate angles are equal. Corresponding angles are equal. So P and Q are alternate, and then R and S are corresponding. So for C, R and S are corresponding angles. Measure the sizes of each angle and label them, and you can see the answers there. And then corresponding angles are equal. Let's do some new learning. Have you noticed that by now we have established, these key geometric facts that we know? Alternate angles are equal, and you can see them here, right? We also know that adjacent angles on a straight line sum to 180 degrees. So these are the alternate angles. You can see them here. You see the blue one here, that's alternate to this one here. They are equal. And the red one is alternate to this one here. They're equal. We also know that adjacent angles on a straight line sum to 180. So we're getting to something here because, have you noticed? Because if this is equal to that, and this is equal to that, and we know that the, adjacent angles on a straight line sum to 180 degrees, it means these two angles, if we add them, they should be equal to 180 degrees. That's actually the fact. So just using colors, you can see the reasoning why these two angles in here between the parallel lines, and that is just on the transversal, why they must add up to 180 degrees. But there is a special name for it. We call them co-interior angles. So here is another geometric fact you must add to your bank of knowledge. Co-interior angles sum to 180 degrees. I repeat, co-interior angles sum to 180 degrees. Now, many years ago, when I was your age, we used to call these supplementary angles. So just in case you see it anywhere, don't get confused. They mean the same thing. We used to call them supplementary angles. But now you should know that it's called co-interior angles. Let's now practice what you've learned. Pause the video and answer question 3 in 2 minutes. So when you have questions like this, you could pause the video, take a screenshot, print it so that you have the worksheet to practice, or buy the, worksheet from White Rose Mats. So here is question 3. Here is the answer. So a pair of co-interior angles are shown on the diagram. A, you will ask, measure the size of each angle, label them on the diagram. What do we notice? When we do that, we begin to notice what we just learned, that the co-interior angles are adding up to 180 every time. So to complete this sentence, you can say co-interior angles sum to 180 degrees. Pause the video and answer question 4 in 3 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Let's discuss them. Here for 4a, you were asked angle A is vertically opposite to angle C, and you can see it here. So by now, you know the angle facts that we've learned, the geometric facts that we've learned. Angle A is corresponding to angle E. You can see it there. Angle H is alternate to angle B. Angle H is alternate to angle B. And you can sort of see the Z shape that links them. Angle H is corresponding to angle D. Angle H is corresponding to angle D. And you can sort of see the F shape that links them. And then angle H is vertically opposite to angle F. H is vertically opposite to angle F. And you can see how they are vertically opposite. And you can also see it with G and E as well. Angle D and C and AFC are adjacent angles on a straight line. All right. You can see it here. Angle D, A, or C. Yeah, you can see it here. D to A and then to C. They are alternate angles on a straight line. Yeah. Sorry, adjacent, not alternate angles, adjacent angles on a straight line. So they would sum to be 180 degrees. Angles D and F are alternate angles. So D and F are alternate angles. Angle H and D, H and D are corresponding angles. And you can see the F shape that links them. And that's the answer to the other last question. So let's move on. For C, for question 4C, you were asked to complete this. So pause video and answer 4C in 1 minute. Assuming you've paused the video and you have answered the questions, here are the answers. Let's discuss them. So AXF is alternate to EYD. So AXF, which is this angle here, AXF, is alternate to EYD. So it should be alternate to EYD, this angle here. AXF is corresponding to CYF. So AXF, so this angle, must be corresponding to this angle. DYF, DYF, so which is this angle, must be corresponding to this angle, which we'll call BX. All right, BXF. Okay, BXF. DYF is vertically opposite, so DYF, so this angle is vertically opposite to EYC. So EYC. So you can see it's vertically opposite to this one. All right, so mark your work and celebrate your success. Let's move on. Pause the video and answer question 5 in 1 minute. Assuming you've paused the video and you've answered question 5, here are the answers, okay? So here you were asked, work out the sizes of the unknown angles and label them on the diagram. So to work this out, we know that's 49, so that should be 49 because, why? Because they are alternate angles. So now that we know these are alternate angles, we can use our knowledge of adjacent angles on a straight line adding up to 180 to find this angle here. So we can subtract 49 from 180 degrees to get this angle. And then you say, well, that angle has to be alternate to that angle. So that should be 131 degrees as well. Now, notice that there is more than one method of getting the same answer. So we could have got this as 49 degrees, and we could have used our knowledge of having co-interior angles summing to 180 degrees to get that angle. So we could have said 180 degrees minus 49 degrees will be 131 degrees. And then if we're asked to give a reason for the answer, we would say co-interior angles sum to 180 degrees. So take note that if you're working with a partner, you could get the same answer but different reasons for the same answer, and you would still be right. And then once we know that this is 131 degrees, that should be 131 degrees as well. Vertically opposite angles are equal, and we can do that the same here as well. All right, let's do some new learning. Are line segments AB and CD parallel? Have a think. How would you prove whether they are parallel or not? Well, remember what we've learned so far, that if they are parallel, then the co-interior angles must sum to 180 degrees. Looking at this, that is the only information we seem to have to help us prove whether they are parallel or not. We're not going to have equipment to start measuring to see whether they're actually parallel. Using the numbers, if they were parallel, then the co-interior angles must sum to be 180 degrees. But in this case, they sum to be 181 degrees, so they're not parallel. Okay, here is another question. We've been told that GH and IJ are parallel line segments. A and B are of the ratio 1:3. So what this is telling us is that angle B is 3 times bigger than angle A. Now, if you think about it, there are different ways to answer this, but one way is by using the bar model. So we know that these are co-interior angles, right? So it means they should actually sum to 180 degrees. So altogether, thinking about this as boxes, we actually have, using our bar model, all right, A and B adding up to be 4 parts. Now, this 4 parts is equal to 180 degrees, which means each of these parts should be 45 degrees. So it means A is 45 degrees and B is 3 lots of A, which is 135 degrees. We could have done this in a slightly different way because remember, in maths, your skills can always come in useful. So I want us to use our equation solving, skill to solve this problem. So if thinking about this ratio, it means B is 3 times A. Yeah, 3 lot is 3 times bigger than A. So imagine that we say let this angle be X, and we also say that, well, if this is 3 times bigger, then this has to be 3x. So we could have done this to say, well, these co-interior angles must sum to be 180 degrees. So actually, we can form our equation to be this, which means 4x will be equal to 180 degrees. Of course, to solve equation, remember we have to divide both sides by 4. Remember your equation solving skills, which will give us exactly the same thing as thinking about it using our bar model. So x will be 45 degrees, which represents the A we have here, and B will be 3 lots of that, which represents the same answer. So remember, there is more than one way of thinking about the solution to the problem. Here is this one. Our last example, I presume. Here he says we can't work out the size of angle, and notice the way this notation is used, to talk about angle. So that little notation there, when you see it, it means the angle, and the middle letter tells you the location of the angle. So angle WAY, we can't work it out because it is neither corresponding nor alternate to angle ABV. Do you agree? Have a think. Well, I won't agree because we can say, well, angle WAY is vertically opposite to BAX. So it's vertically opposite to this angle here. Now, if it's vertically opposite, we also know that co-interior, it is co-interior with angle ABV. So these two angles, so this angle here, which is angle BAX, must add up to this angle 125 degrees to get 180 degrees. So if we can find this angle must also be equal to the angle WAY that we're looking for because they're vertically opposite. So we'll disagree with Mo. It's now time for you to pause the video and practice what you've learned. So pause the video and answer question 6 in 3 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. Let's discuss them. So for question 6a, you were asked to work out the size of the unknown angles. This angle has to be 87 degrees. How did we get that answer? So we know that this angle here has to sum to 93 degrees to get 180 degrees. So they are adjacent angles on a straight line. So to get this angle, we could say 180 degrees minus 93 degrees, which will give us 87 degrees. And of course, we know that that angle there is alternate to this angle here. So P should be 87 degrees. Here, we know that this angle here is 51 degrees. Now, it's 51 degrees. It should be vertically opposite to the angle here. So this should be 51 degrees as well. Now, notice that this is a transversal, so it means the co-interior angles must sum to 180 degrees. So it means to get that angle Q, we know that Q at 51 degrees will be 180 degrees. The reason is they're co-interior. Now, to get Q, we can simply subtract 51 degrees, all right? So again, your equation solving skills, and that gives you 129 degrees. Here are the answers for C and D. Let's discuss them. So, but first, I'll need to rub this off. Okay, so for these, you can see that they are, all right, you can see that we can use this angle here to get this angle here, all right? So this will be alternate, so that will be 81 degrees, to be 81 degrees here. And then if it's 81 degrees there, then it should be 81 degrees here as well. They're vertically opposite, okay? Now, if this is 81 degrees, that has to be 180 degrees minus 81 degrees. So to get this angle here, we'll do 180 degrees minus 81 degrees here. That gives us 99 degrees. And of course, you know that you can see that these are corresponding angles, so R should be 99 degrees. Here, it might look complicated, but it really isn't. So we're trying to get these angles. So we know that this is 78 degrees. Now, if that is 78 degrees, then it means co-interior angles must sum to 180 degrees. So we can, find this angle here by doing 180 degrees minus 78 degrees. Now, whatever angle we get there will have to be, just a minute. Yeah, so for S, sorry about that. Um, so for S, if we there is more than one way to do it, but so this will be 78. That will be corresponding to this angle here, and would also be corresponding to that angle there. So that would be 78 degrees. And then for T, so we know that's 78 degrees. So for T, we know that these two are co-interior. You can see that, they are lying on the same line. So if we do 180, so let's 180 minus 78 degrees. No, that's not what we should do. So so first we can get this one here. So let's use this approach. So if we get this one here, that will be 83 degrees, right? So why? Because the sum of the alternate angles on a straight line would be 180 degrees. So if we do 180 degrees minus 97, that will be 83. That will be corresponding to that one and will also be corresponding to that one. So that will be 83 degrees. Now, this is a triangle. So to get that one, we can now add 78 to 83 and then subtract it from 180 degrees to get U equal to 19 degrees. But there are other ways that we could have used to solve the problem, but I don't want this video to be too long, so let's stick to that. All right, for question 7, pause the video and answer question 7 in 2 minutes. Assuming you've paused the video and you've answered question 7, here are the answers. Let's discuss them. So for question 7, you were asked, are line segments AB and CD parallel? How do we prove, just using numbers, whether they are parallel or not? Well, if they're parallel, it means that the sum of these angles here on a straight line. So first, if we find the sum of the angles on a straight line, alternate angles on a straight line, they should sum to 180 degrees. So to get this angle here, we can simply do 180 degrees minus 132 degrees. Now, once we have achieved that, we can see that these are corresponding angles, but they are not equal. All right. So it means these lines are not parallel. So just using, number computations, we can say that these line segments are not parallel. And that brings us to the end of our lesson. So in this lesson, you have learned how to use parallel line angle rules to solve different problems and even to prove whether lines that seem parallel are either parallel or not. So well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself and bye bye.